Hi everyone. The purpose of this video is to show you how to balance chemical equations using the inventory method. In the previous video, I showed you how to think through this using particle diagrams, and I think particle diagrams are really essential to understand exactly what's going on in a chemical reaction and why we need to balance the chemical equation. But I think that this inventory method of balancing chemical equations might make things easier for you. So I just want to run through this. This is the worksheet that was assigned, and I just want to choose a couple to maybe work through with you. All right, so we're going to look at this chemical equation first. We're going to use the inventory method of balancing. Okay, now the goal to what we're doing here is to make the number of atoms of each element the same on the product side and the reactant side. So we cannot create or destroy atoms. That means the number of carbons that we start with must be the carbons that we end with, and so on for the hydrogen and the oxygen. Okay, so that's the goal. Now, the only thing that we can work with here are the coefficients. So the numbers that go in front of these symbols are the only numbers that can be changed. We cannot touch the subscripts, okay? Okay, so to start, I'm just going to draw a line under the chemical equation, and where the arrow is, I'm going to draw a line down. Okay, now what I'm going to do is I'm going to write out the number of elements on the reactant side and the product side. On the reactant side, we have carbon and hydrogen and oxygen. And on the product side, we have carbon and hydrogen and oxygen. Okay, now we need to count these out. On the reactant side, I have one carbon. There's just one carbon there. I'm going to write that one there. On the product side, we have one carbon, so I'm going to write one there. On the reactant side, I have 4 hydrogens. On the product side, I have 2 hydrogens, the 2 hydrogens that are with the water. And then on the reactant side, we have 2 oxygens, and we have 3 oxygens here. We have 1, 2, 3 oxygens on the product side. Okay, so like I said before, the numbers on the left side must match the numbers on the right side. And the only thing that we can do is to work with the coefficients in the chemical equation. All right, so I'm looking at this, and my carbons are already balanced. So I've got 1, and I finish with 1. But with the hydrogens, I'm starting with 4, and I'm ending with 2. So we need to deal with that. And I think whatever changes I make now, I'm going to put in red. All right, so in order to make the hydrogens equal, I need 4 hydrogens on both sides. In order to make that 4 hydrogens possible, I need to add a coefficient of 2 in front of the water. Okay, what that is giving me now are 4 hydrogens. 2 times 2 is 4. All right, now along with when I put this 2 in front of the water, along with the 4 hydrogens now, I have 2 oxygens, right? Because I have 2 water molecules. I have 2 oxygens plus the 2 that we already had. Now that makes 4 oxygens. All right, so with the carbon, 1 and 1, we're good. With the hydrogen, 4 and 4, we're good. With the oxygens now, I have 2 oxygens on the reactant side and 4 oxygens on the product side. So we're going to change this 2 to 4 to match. Now, in order to make 4 oxygens on the reactant side, I need a coefficient of 2 with the oxygen. Let's check our inventory now. We've got 1 carbon, 4 hydrogens, 4 hydrogens, 4 oxygens, 4 oxygens. We're equal with everything on both sides. And the way that we did that is we reacted 1 methane with 2 oxygens to make 1 carbon dioxide and 2 waters. And we're finished. This is our final answer. This is our balanced chemical equation. Let's try another one. Okay, now I'm on page 3 of this worksheet, and we'll take a look at number 1 together. All right, so here's number 1 on page 3. I'm going to start the way we started before. I'm drawing a line across, and where the arrow is, I'm drawing a line down. Okay, I want to list the elements on both sides of the reaction. I've got nitrogen on both sides, and I've got hydrogen on both sides. All right, that's what we have. And currently, as it's written in our skeleton equation, we have 2 nitrogens, we have 2 hydrogens. On the product side, we have 1 nitrogen, and we have 3 hydrogens. All right, now we need to balance this. And whatever changes I'm going to make, I'm going to do in red now. Okay, the way I'm going to approach this now is I'm going to start with the hydrogen. All right, I have 2 hydrogens on the left side and 3 hydrogens on the right side. What is the one number that 2 and 3 could go into? That would be 6, okay? If I take 3 times 2, I will get 6. All right, I multiplied by 2, so I'm going to use a 2 for the coefficient. Now I have 6 hydrogens on the right side. In order to make this 2 6, I need to multiply by 3, okay? And that means I'm going to put a 3 in the coefficient for hydrogen. Okay, so now my hydrogens are balanced. When I put this coefficient of 2 up here for the ammonia, I now have 2 nitrogens, so that needs to change. Okay, now I have 2 nitrogens instead of 1 nitrogen. And now I'm looking at this, and we've balanced it. We have 2 nitrogens and 2 nitrogens, and 6 hydrogens and 6 hydrogens. And this is our balanced chemical equation. Okay? Now, we won't often write a 1, let's say, like for instance, for nitrogen here. The 1 is always understood, but for right now, just to really emphasize, we have 1 nitrogen combining with 3 molecules of hydrogen to make 2 molecules of ammonia. That's NH3. All right, let's try another one. Okay, this is number 2. I'm going to start by drawing a line under my equation and then a line down at the arrow. I'm going to count the elements on both sides. I've got nitrogen, I've got oxygen, nitrogen, and oxygen. And on the left side of the equation, as it's written, I have 2 nitrogen atoms. I have 2 oxygen atoms. On the right side of the equation, I have 2 nitrogen atoms and 1 oxygen atom. All right, now it's time to balance this and make the atoms the same on both sides. And why don't we just look at the oxygens now? We have 2 on the left side, 1 on the right side. Well, let's make that 2 on the right side. And in order to make that a 2 oxygens, we need a coefficient of 2. for the N2O. Okay, now having done that, now we've got 4 nitrogens on the right side. So let's change that 2 to a 4, okay? And looking at the nitrogen on the left side, we need to make this balance, so let's change this 2 to a 4. In order to make that happen, we multiplied 2 by 2. So that means we're going to use a 2 coefficient for that nitrogen. And now we're done. We have 4 nitrogens on one side, 4 nitrogens on the other. We have 2 oxygen atoms on one side. We have 2 oxygen atoms on the other side. And we have created a balanced chemical equation. We have 2 nitrogen molecules combining with 1 oxygen molecule to create 2 N2O molecules, or dinitrogen monoxide molecules. Okay? All right, I'm hoping that this is enough to get you started. I will have the answers to this worksheet posted. Again, I think for this worksheet, really for the entire worksheet, I would encourage you to use this inventory method. If you like working with particle diagrams, that's great. I would say whatever works for you is perfect, okay? The bottom line is what we're trying to do here is balance chemical equations, all right? So good luck, everyone, and if you need to see the answers, they'll be in the student resource folder. Thanks.